Bismillah ar-Rahman ar-Rahim. This is about the several videos showing helicopters or choppers with rotors that appear to be fixed or stationary. For example, what we have seen is due to a certain relation between F1 and F2. F1 is the frame rate of the video camera. This is the number of frames or shots per second. F2 is the rotation rate of the main rotor of the chopper in units of revolutions per second. If the video camera takes F1 shots per second, then the time between two consecutive frames or shots is 1 over F1 seconds. What happens to the rotor in this time duration is that it is rotating. Let's take a specific example in which we have 5 blades. So at one shot, this is what the rotor looks like, and here the assumption will be that the blades are uniformly spaced over the disc. So this angle here is 2 pi over 5. Let's number the blades 1, 2, 3, 4, and 5. Then after 1 over F1 seconds, that's the intra-frame time. It's the time between two successive frames by the video camera. Suppose that during this duration of time, the speed of rotation is such that the rotor rotates by an angle double this number in radians, so 4 pi over 5 radians. Now, when you take the next shot, what you will see is exactly the same thing. And that's the reason that the rotor will appear stationary. It is rotating, but what has happened is that now this is blade 1, this is blade 2, this is blade 3, this is blade 4, and this is blade 5. There was a rotation which is 2 times 2 pi over 5 during the same time interval between two successive shots. It gives us the perception that the rotor is stationary, while in fact it is rotating. A rotor that is apparently not rotating is due to a certain relation between these two parameters, F1, the video camera frame rate, and F2, the number of revolutions per second. This relation will make us see a fixed rotor or stationary rotor. We see a fixed rotor if during this time interval, 1 over F1 seconds, the rotor rotates by an angle that is equal to 2 pi over b, where b is the number of blades, or an integer multiple of 2 pi over b, like 2 times 2 pi over b, or 3 times 2 pi over b, and so forth. The relation that should be satisfied so that we see a fixed rotor is that the rotation angle during the time between two successive shots or frames. So what is this? So we take F2, which is the number of revolutions per second, we multiply by 2 pi. So this will be the angle in radians that the rotor rotates in 1 second. Per second, this is the angle of rotation in radians. If we multiply this by the time, which is 1 over F1 seconds, then we get the angle in radians that the rotor rotates during the interval between two successive shots. So this will be the angle. If this angle is equal to a positive integer multiple of the angle between two neighbor blades, then we obtain the fixed rotor seen. Eliminating 2 pi from both sides, we get the relationship that F2 to F1, this ratio, F2 is the number of revolutions per second, and F1 is the number of frames per second. If this ratio is equal to some positive integer over the number of blades, then we see a fixed rotor. For example, suppose that you have a helicopter in which the main rotor rotates, say, 360 revolutions per minute. So per second, there are 6 revolutions. And suppose that you have a video camera and it takes 30 frames per second. And the number of blades here, 1, 2, 3, 4, 5. So B is equal to 5. And then F2 to F1, that's 6 over 30. And this is exactly 1/5. This equality here is satisfied with positive integer m being equal to 1. In this case, we see a fixed rotor. If this expression is not satisfied exactly, so if the left and right hand sides differ slightly, then the rotor will appear to us to be rotating either clockwise or counterclockwise, but with a speed of rotation that will look much slower than the real speed of rotation. Another thing, if we see the blades in the video, is their number the actual number of blades? Let's think about this situation. If we have 3 blades, and suppose that the rotation speed is such that in 1 over F1 seconds, which is the time between two successive frames, the rotor rotates by an angle which is not 2 pi over 3, but pi over 3, 60 degrees. So at one frame, we see the rotor in this black position but then in the next frame, it is in the blue position, and so forth. Due to vision persistence, we may see what looks like a fixed rotor with 6 blades. The general idea is that if we see V blades, it may be that the actual number of blades is V, or perhaps V is a multiple of the actual number of blades. If the number of blades is 2 or more, then if we see 6 blades, it may be the case that there are 6 blades, or perhaps a factor or divisor of 6 greater than 1. So perhaps the actual number of blades is 2 or 3. If we have 5 blades, and because 5 is a prime number, then the rotor does indeed have 5 blades.